Okay, welcome Aaishika. Thank you for meeting with us today. Oop, we lost her. I don't know if Aaishika, you realize you're on mute.
I had to take a quick break because of the roommate issue, but greetings of the day, everyone. Thank you so much for having me here and for such a warm welcome. I am Aaishika, and today I'm going to be delivering a session on how to collaborate with GitHub. Hopefully I'm audible and visible. So let's take a deeper dive. So once again, I'm Aaishika, and I'm currently a junior developer advocate at DigitalOcean. I've also been an MLH coach in the past, and I've led several tech communities in and around my city, Chennai, in India. I am a proud GitHub Campus expert, and if you're interested in knowing more about hackathons, I also have a stream on GitHub Campus TV that goes by the name of #hacking hackathons, which might be useful for you if you're a beginner or an intermediate level hacker. So let's take a dive into all the things that we are going to cover today. So I am going to be talking about the basics of Git and Github. We'll learn more about the GitHub workflow, all sorts of different flows that we have to get things up and running. We are going to be talking about command line Git usage, and I'm going to give you a thorough run through the basic Git commands that are going to be useful to you. There's also going to be a hands-on session on creating your first pull request. And I would love to have this session be as interactive as possible. Any questions that I ask don't have any wrong answers unless you try really hard. So please do answer all the questions that I have for you. If you want me to answer your questions, feel free to unmute at any point of time or drop messages in the chat section, and I'd be more than happy to answer them for you. So the outcome, if we talk about it, what does this workshop really offer? You'll be able to learn more about how you can collaborate effectively using GitHub. You'll learn how to code and work with the command line interface that Git offers. You're going to learn how to contribute to all sorts of open source repositories and open source stuff, and you'll be able to learn and grow with developers worldwide on GitHub. So if you don't have any questions right now, I would love to jump into a brief introduction to Git and GitHub. So any questions for me so far? You can also add a no in the chat section. That would be helpful if you don't have any questions. And hopefully everything is clear as of now. Please feel free to unmute as well. That would actually be more helpful, because I'm not able to access the chat section as efficiently. Okay. So I guess we can get started with introduction to Git and GitHub. So first up, there's a very big question. What's the difference between Git and GitHub? So Git, as you can see here on the screen, is a version control system which can be used with various tools or locally on your computer to help you keep track of changes in your code projects. Think of it like Google Docs for code, but better. On the other hand, GitHub is a platform for code collaboration. So GitHub actually uses Git for version control and provides you with all sorts of awesome collaboration tools. So Git is a version control system, and consider GitHub as the graphical user interface that you can use to handle all things Git and share things across with other people. Now, I've used the word version control system or the phrase version control system. Let's see what version control system actually means and why it's useful. So let's talk about why we need version control in place. It's simply because emailing a file around is painful. Before I personally started using Git for managing my projects and collaborating with my friends, I used to email around files, which was very popular back before 2019, before I was introduced to Git. Me and my friends were introduced to Git and GitHub. So two very important features of version control system are that you can log changes in a searchable way. So instead of renaming a file for each version, you can actually work on the same version and you can commit or add as many changes as you want to. And if, say, for example, your code breaks because of certain edition, you can always roll back to the previous edition instead of going Control-Z. And apart from that, collaborators can work in parallel and merge their changes automatically instead of manually comparing the differences between a file, which would be a headache if you're working on large code bases. So hopefully these illustrations would help you visualize what I'm talking about. So if you're not already a GitHub user, I would highly recommend heading over to github.com to create a free account right now, because we are going to have a couple of hands-on sessions today. And if you're a student, please head over to education.github.com to avail the extra benefits that you can have as a part of the GitHub Student Developer Pack. So I think I'm going to wait for 2 minutes for you folks to create an account on GitHub if you don't have one already. If you have one, it's going to be a small break for you. And in the meantime, if any of you have any questions for me, please feel free to reach out. If you already have an account on GitHub, by the way, you can just maybe add the same in chat section, so I know how many of you are going to create an account now and how many of you have one already. So I'm guessing that all of you already have a GitHub account or have successfully created one now. So I'm going to jump on to the next slide. So talking about the interface that you're going to see as soon as you log into GitHub, you have this beautiful dashboard. We are going to explore some components of the dashboard that you see here, and I've also highlighted them on the slide, so it's easier for you to compare it with the dashboard that you have. So talking about the pull request tab that you see here, first up, pull request, it's a way to ask to make changes to somebody else's code by submitting your own changes for the review. Today, we are actually going to open a pull request if you haven't opened one already. And talking about pull requests, the GitHub platform provides numerous features for collaboration. Next to the search bar, you can see the pull request tab. This will show you your own pull request against other people's repositories. Now, talking about issues, issues are a way to share a problem about somebody else's code without necessarily submitting your own solution. And next to the pull request tab, you can see any issues that you have opened or worked on recently. Then account controls, in the upper right-hand corner, you can see any notifications that you have received, on any issues that you may have opened, any updates on the pull request that you have opened. The plus symbol adjacent to that allows you to create a new project or a new repository. Clicking on your avatar opens the settings menu that can be useful for you in numerous ways. You can always explore. And let's talk about repositories now that I mentioned previously. So think of a repository like a project folder where all the code is stored. It's basically your code base, but posted on the internet. So I have created a small repository for all of you to check things out. So definitely feel free to navigate to the URL below and let's check out the repository for all the things that we are going to do today. So it's going to be github.com/aishikasb/HACC-workshop. So I'll also post this in the chat section. I'm not able to access the chat, so please feel free to unmute. Okay, I can see the messages now. I'm going to post.
No questions have been asked yet, by the way.
Yeah. Can you, by any chance, help me out by? Okay, wait. I made the button. So there's a link in the chat section for all of you to check out. This is the repository that we are going to be using for today's session. So it's going to be github.com/AishikaSB, which is my username, followed by the name of the repository, which is HACC Workshop. And I'm just going to give you a run through the user interface that you can see on GitHub whenever you click on the link or whenever you visit the link. The first tab in a repository is the code tab, and it shows the code as well as the files in the project. So the code tab basically showcases the code base of the repository, all the working files and stuff. Following that, you can see the second tab, which is the issues tab, how it's different from the issues tab on the header of github.com. It actually is going to show only the issues that exist for this specific repository. The issues tab on the header of github.com, it shows any issues that you have opened on other people's repositories as well. But this issue tab for the specific repository is just going to represent all the issues that exist for this single repository. So if there is a problem with the code in someone's project, you can always open an issue and let them know about it. Pro tip, you should always follow the project maintainer's instructions for opening an issue and make sure that they're as elaborate as possible. So it's easier for other fellow developers to basically solve the issues. Now talking about the pull request tab again, the third tab is the pull request tab. If you want to contribute code to someone's repository, you'll open a pull request, and we are going to do that today. So again, the pull request tab that resides in the repository, it's only going to represent all the pull requests that exist for this specific code base for this specific repository. So this brings us to the second section of the workshop, which is the GitHub collaboration workflow. If at any point of time you are stuck or if you have any questions for me, please feel free to unmute or drop a message in the chat section, and I'll be more than happy to answer your queries. So let's talk about the GitHub collaboration workflow now. So this is the typical best practice developer workflow that pretty much all of us follow. First up, we are going to fork someone else's code, and this means that we are going to be creating our own copy of it. Then you'll create a branch, and a branch is just a parallel version of your copy where you'll test your own changes. Talking about the key terms, forking a repository is basically copying somebody else's repository onto our profile. The reason why we fork repositories is so, we don't end up breaking code in somebody else's repository, and we can just experiment as much as we want to in our own copy of it. So if, say, for example, I've actually forked someone's repository, what I've done is I've just copied their files onto my GitHub account, and I am free to experiment as much as I want to. Once I'm happy with the changes, I can always, try to merge my fork with the original code base. And that's pretty much how it works. A branch, on the other hand, is just a parallel version of the main copy of a repository. Making a branch basically allows you to edit code without accidentally breaking a working version. So if, say, for example, you're not very comfortable with forking a repository, even though it's best practice to fork a repository, then creating a branch, then opening a pull request, you can also create a separate branch, which is going to sort of diverge from the main code base. And you can add any changes. You can request both the branches to be merged. And we are going to talk about all of that stuff in a while. I'm going to give you, a hands-on session on how you can actually go about the whole thing. And post that, we are going to stage changes as we go. When you're happy with them, you'll basically be committing all of your changes. So to commit is to basically officially add code to your branch. And if you want to add your code to somebody else's project, you'll have to open a pull request. If they approve it, they'll merge your branch into the main branch. So there are three key terms here, as you can see. We have the staging phase, which basically means adding to a cohesive group or bundle of revisions. A commit is basically a group of revisions that you want to officially add to your branch, and merging is to officially add changes from your branch into the main branch or any other branch which serves as the master branch, or the branch that is supposed to be deployed. And yeah, talking about the network activity workflow, as you can see here, there are many ways to use GitHub. Today, we are going to use a very common developer workflow, which would be the network activity workflow. The first thing that you would want to do is fork the repository you want to contribute to. So for us today, it's going to be the URL that I shared with you previously. So do check out github.com/Aaishika with AA/HACC-workshop. That is the repository we are going to be making changes to. The first thing that you need to do is create your own copy of the repository. You can simply do that by clicking on the fork button that I've highlighted here. Feel free, take your time. If you would want me to pause, take a break, do let me know. And apart from that, the second thing that you're going to want to do is you're going to click on create a branch. You should always try to name branches with your name and what you're doing, or follow the convention set by your team. And this is extremely helpful if you're contributing to open source, if you're contributing to repositories that are not owned by you. It's standard practice to always name branches with your name in addition to what you're doing, or you can always check out different documentations like contributing.md on the repositories that you're planning on contributing to. So if you would want to see how to create a branch, I think we can do that. And give me one moment. I'm going to head over to GitHub. Yeah. So let me just share my screen once again. So this is the repository that we are going to be contributing to today. So the first step here is to fork the repository. Somebody has already forked the repository, which is great. Now, after you're done forking the repository, you can go to your own fork. I cannot fork my own repository, so I won't be able to create a branch on another fork. So I'll just tell you how you can create a new branch. You see this main branch here. It says one branch. I just have to click on this drop down here which says main. I can always find or create a branch. So I'm just going to add new branch. And then I just need to click on this tiny button which says create branch, new branch from main. So using this, I've basically created two different branches of within the same repository. We have the main branch and the new branch. Now I can push a specific combination of code that will maybe serve as a new feature and deploy it separately. I can deploy the main branch separately, and that's why branches are pretty useful. So going back to the presentation, you can now open readme.md. You can select the edit icon, which looks like a small pencil. So I'm going to show you once again how that can be done. This is a simple code base. We just have one file, which is readme.md. Either ways, if you ever want to contribute to readme.md, you can see a small pencil icon right beside readme.md. But if, say, for example, there were a good number of files here and you wanted to contribute to a single file, you can just click on the file and then find the pencil icon again. So this is basically what you need to click on to make any contributions using GitHub's graphic user interface. So again, going back to the presentation, give me one moment. Is the screen loading for you folks?
Yes.
Load it for me. Perfect. Thank you.
Mm-hmm.
So talking about the network activity workflow, feel free to add your name with your city and choose a blank line to do so. So what I did previously, I just have to click on this pencil icon. I can see name and city here. I just have to type my name, which is Aaishika. My city, where I'm residing currently, would be Chennai. And now all that I need to do is scroll to the bottom to the commit changes section. So commit changes is where I basically propose my code changes to be recognized officially. So it's standard practice again to sort of describe all that you're doing here in the dialog box. So I'm not going to change update readme.md because that's pretty much what I did. Optional extended description would be added name and city. And now I can commit directly to the new branch here that you can see. And once I click on commit changes, you'll see that readme.md now reflects all the changes that I just made. Now you'll notice one thing. We added a descriptive message, we selected commit changes. Now when we return to the main page of the repository, we can actually see this small dialog box which says that we can open a pull request. Because this is a simple pull request, you can simply select create a pull request. If you are contributing to an open source project, you would want to be very descriptive about the changes that you made. So we are not going to dive into conflict resolution today. As you can see here, the new branch had recent pushes less than a minute ago. So again, the default branch, the master branch that we are working on in this repository is main, and new branch is just a diversion from the main branch. So we actually have the option to compare both the branches and open a pull request to suggest changes that can be added to the main branch. So opening a pull request is actually very easy. We simply need to click on compare and pull request. This is a very simplistic pull request, so there's not a lot of things that we need to do. I don't want to change the contents here because it looks fine to me. So I'm just going to click on create a pull request. You can also see that, it's running some checks for me. It's checking if, there are any conflicts. We are going to be talking about conflicts in just a while. Since this branch has no conflicts with the base branch, merging can be performed automatically. So all that I need to do, since I am the owner of this repository, I have the option to merge pull request. If you don't have access, if you don't have collaborator access to a repository, you might not be able to merge the pull request, but the maintainer would be able to. So right now I am the maintainer. I am going to confirm this merge. And as you can see, pull request successfully merged and closed. Now I also have the option to, safely delete the branch that I just created, which would leave me with just one branch main with all the updates that I created to new branch. So let's go ahead and delete this branch safely. Now note one thing, that I can also restore this branch. Say for example, if main breaks for me and I'm not satisfied with how it looks, I can always restore the branch, continue working on it, and all of that stuff. So when we again click on the code to access the code base, you can actually see all the changes that I've created here. They are reflected now in the main branch, which is the only branch that exists in the repository now. So again, when we go back to the slides, let's talk about conflict resolution, a small dialogue that we saw while creating a pull request and while trying to merge it. So when a file has multiple edits, it can be unclear which change should be committed. This is a conflict and must be resolved before merging. So say, for example, if there were 3 people simultaneously working on a single file, suggesting changes throughout, there is a very high possibility that all 3 of them, make changes to the same piece of code. So in that case, it basically leads to a conflict because you now need to decide whose code gets to stay and whose code you have to check out. So this is basically what is meant by conflict resolution. So whenever you click on resolving conflict, resolve conflict, you can see that it is marked by these 3 main pointers. The first one is all the changes in the new branch, and right below that you can see the original code. You can choose whose code gets to stay and whose doesn't by just simply removing these angle brackets that you see here and keeping the code that you want to have. So edit the file to the desired state, mark it as solved, mark it as resolved, and then merge it. And that's really how easy it is to resolve conflicts. And this brings us to our third section, which would be GitHub and the command line. So if you have any questions for me so far, please feel free to reach out. This is going to be a very code heavy section, and we are going to be talking about all the different commands that we can use in Git. I'm going to tell you about how you can configure Git in your system. You all need to download Git, and I think we have sufficient time to do that too. So I guess no one has any questions as of now. Do we have any questions? Sorry?
I said none in chat.
Okay, perfect. Yes, I am very clear then, which is a big achievement for me. Thank you. So, okay, let's talk about GitHub and the command line then. So once you start working on projects that are more complex, you might find that you prefer using your own local coding environment with GitHub. So for me personally, I absolutely love using Visual Studio Code, and I think a lot of you are familiar with what it is already. You have the ability to download some cool extensions that make your workflow very easy. So that's why we basically need Git to work on more complex projects and from within our own local coding environment. So let's learn how to set that up, and we'll also learn how our local environment works with our repositories on GitHub. So the first thing that you need to do is install Git. To see if you already have Git installed on your computer, type Git followed by space -- version in your terminal, PowerShell, or any terminal application that you may have. So if you are a Mac user like me, you might want to head over to terminal. If you're currently using Windows, you can head over to PowerShell. If you're using Linux, again, it's going to be terminal for you. So simply execute Git space -- version. If you already have Git installed, you're going to receive this small reply from the terminal stating the version of Git that you have, and if you already have Git installed, feel free to skip the next few slides. So if you don't have Git installed, all you need to do is head over to git-scm.com/downloads. If you do not have Git installed, navigate to the URL above, select your operating system, and the installer will download. It might take some time for you to get it up and running, but I'm going to continue with the slides. If you would want me to stop at any point of time, do let me know. So if you are installing Git on Mac OS, all you need to do is open the installer once it's done downloading, follow the instructions in the installer package, and it should be fine to select all of the default options. There's actually no harm in going with all of the defaults. It's actually recommended. And if you're using Windows right now and you're installing Git, open the installer and follow the instructions. It should be fine to select all of the default options except for the one below. We recommend choosing your preferred text editor in this step because Vim can often be painful for beginner developers. So if you are using, say, for example, Visual Studio Code, please select your default editor as Visual Studio Code, which might already be installed in your system. If you are an Atom fan, you can always use Atom or any other code editor of your liking. I would highly recommend going against Vim, which is pretty difficult to deal with for beginner developers. So once again, once you're done downloading everything, once you have everything up and running, simply restart your terminal, PowerShell, or Git Bash. I'm not going to take a deeper dive into Git Bash today. Run the command that you ran a while back, which would be git -- version, git space -- version, which simply gives you the version of Git that you have installed on your system. If this is not what you see, if you don't have Git installed, even after installing it from git-scm.com/downloads, please let me know in the chat section. And I think apart from that, we are good to go. So if anyone has any difficulties installing Git or working with Git so far, please feel free to actually unmute because I'm not able to read the chats. So just unmute, let me know about your issues, and we are going to work our way through that. Moving forward, you would want to configure Git, in your local environment, so that the correct GitHub account is associated with our commits. So whenever you're creating contributions, you want your profile to be the one making commits to any repositories that you might want to contribute to. So on GitHub, simply find your username, and you can find it by clicking your avatar on the upper right-hand corner that we explored in the first couple of slides. It will simply say signed in as. So this is going to be your username on GitHub. So as you can see, it's Aaishika SB for me. This is going to be my username. Now we would want to, return to the command line or terminal, whichever we are using, and execute the following commands, which would be git config space -- global space user.name followed by the username that we have on GitHub. So basically what we are doing here is we are configuring Git to recognize our username and our email that is going to be associated with all the commits that we try to push. So using the global flag, we are just letting Git know that globally any commits that are generated through this specific device, they are going to be associated with this specific GitHub account. So using the two commands that we see on the screen here, we are going to be setting up our username and our user email. So once you're able to execute this, you can also double check it if you have successfully been able to configure your username and user email by simply removing the global flag, and you can also omit out anything that you entered after user.name and user.email to just double check if you have successfully configured Git on your command line. So I'm going to give you all 1 minute to execute these, and let me know if you're facing any difficulties. In the meantime, I think I'm going to go take a look at the chat section. Looks fairly clean to me. So going back to the slides, hopefully you all have been able to configure Git on your local systems. So I'm now going to talk about another workflow that we call individual workflow. Some key terms before we actually dive in. Cloning is the process of copying a repository to your computer. So how cloning is different from forking a repository? When you fork a repository, you basically create a copy of it on GitHub. It's a remote copy, which is not available locally on your computer. To bring any repository locally onto your working system, you need to clone the repository and create a local copy of the same on your computer. And we previously talked about staging, but I'll just briefly describing again. It's the process of saving your changes so they are ready to be added to your branch. Okay, so you can clone any repository that you have access to using git clone, and then you can basically create a new branch with git followed by branch followed by name of branch. Also, it's standard practice to not add any spaces in between words when you're naming a branch. And once again, we created a branch previously on GitHub. We used GitHub's interface to create a branch. If we are creating a branch in using the CLI, we simply need to go with git followed by branch followed by name of branch in double quotes. So after you make changes, you'll basically use git add to stage all the changes. Any questions, any doubts, any queries so far? So I'll take that as a no. So moving forward, we are also going to be using the term push, which means adding.
Question. Sorry, there is one question.
Right.
Hannah is asking, how do I find the Mac OS terminal?
Okay, so if you want to head over to your macOS terminal, you simply need to head over to Launchpad and you need to type terminal. I I'm not sure if I'll be able to show you the entire thing. I think I can. So I hope my whole screen is visible right now. So all that I need to do is I need to go here in Launchpad, and I am going to type terminal, and this would give me access to the terminal. So now if I type git dash dash version here, you can see the version of Git that I have on my system right now. So whenever you want to access terminal on macOS, simply head over to Launchpad, type terminal or find terminal, whichever works best for you. And that's how you can access it. And okay, all good. I am going to start sharing the screen once again. And coming back to the individual workflow, we already saw how we can clone repositories and work with repositories, create new branches. Now, when we want to add the changes that we made on our computer, our local repository to the remote repository, I see a question in the chat section. Terminal is in the application/utilities folder. That's also one way to access applications. Thank you so much for pointing it out. And yep. So we'll basically be using git commit -m to explain any changes that we have created. The -m that you see here is basically a flag for message. That means that whatever comes after -m is a message explaining your commit. Your commit message doesn't have any effect on your code. It's just like a comment to let other fellow developers understand what this specific commit is going to do. We are going to use git commit to add changes to any branch of our liking. So when you're ready to push your local changes to your repository or your remote repository on GitHub, you'll simply be using git push. This is the individual workflow that we have. Now, once again, another quick key term. What pulling a commit or pulling commits, pulling changes means, it brings changes from GitHub down to your local copy. So with push, we are basically sending changes from our local copy onto GitHub. With pull, we are bringing changes from GitHub to our local copy. So it works both ways, and we have different terms for both the processes. So you can make a pull request and have your pull request merged on GitHub like before. If you have worked with GitLab previously, pull requests are known as merge requests. So you can pull changes from GitHub to your local repository. Now there are 3 phases of Git, and I'm going to show you 2 graphical representations of this, so it's easier for you to understand what's happening here. So the 3 phases of Git are basically the working directory where all the writing happens. This is when you're coding and saving your work. The second phase of Git is the staging area. So when you're happy with a group of changes and use git add, you are staging your changes. These are called commits, and they are like rough drafts that are stored in a bundle. The third phase of Git is a repository. So when you're happy with your commits, you commit them to the repository. These are like final drafts stored more permanently in a drawer, and they are visible to pretty much everyone who has access to your repository. So if you have successfully created a public repository, anyone who visits your repository would be able to see any changes that you have made to it so far. If I were to represent it visually, take into consideration this image of a typewriter, a sort of a desk where you can store all the things that you have already written, and a drawer where you store the files that you're happy with. So the typewriter here would be the working directory where you're going to write all the things that you want to. Again, the staging area is going to be the place where you keep all the documents ready. And once you're happy with all the things that you have written, all the things that you have staged, you move them to the drawer, which would be the repository to be accessed by other people whenever they want to. So to make it more simple, let's take a look at this diagram. So here you can also see the different commands that we need to follow to dive into different phases of Git. So the working directory is the first phase, the most important phase. This is your workspace. And this basically works locally on your machine. When you are ready with whatever you have written, whatever you have coded, once everything works, just you need to execute git add, which is the command that you need to move to the staging area. So the staging area is nothing but your rough draft. And once you're happy with how your draft looks, you can simply use the command git commit to fully push the code that you have written to the final draft, the permanent draft in your repository on github.com. So the two commands that you need to switch into the three phases of Git are going to be git add and git commit. And I think we have that. Okay. Thanks for your time. Thank you so much. Really love it. And going back to the slides. I hope the slides are visible.
Yes, they are.
Hopefully. Perfect. So now we are going to experiment around with the 3 levels of Git. So the first step is to create a repository and to create a new repository on GitHub and work with it locally. From your profile or homepage on GitHub, click on create a new repository. So when you head over to github.com, you see this small section here, which falls under the title, the home for all developers, including you. You can check out this small section, start writing code. So you can simply create a new repository. And as you can see, a repository contains all of your project's file, revision history, and collaborator discussion. So to simply create a new repository, you can maybe add new repo, click on public or private, however you want to have your repository be. And this is one way of creating a repository. Another one is heading over to this plus icon here. Click on that, followed by new repository. After that, you'll be redirected to github.com/new, which allows you to create a new repository. You can also use repository templates if you're a part of an organization that facilitates templates. And now you can add a repository name, a description, check whether you want to have the repository be public or private. You can initialize this repository with a README file, which serves as the documentation file to the repository. And I'm not going to take a deeper dive into the other stuff. These are the things that are going to we are going to be focusing on today. So once we are through, you will see that once you have created a repository, you'll be redirected to the home page of your new repository. So when you click on the green code button here and then click on the clipboard symbol to copy the address of your repo, I just show you what that looks like. One moment. Yeah. So the green button that's here, when I go here, when I click on code and then click on the clipboard symbol, what I am doing is I'm copying the URL that I can use with git clone to create a local copy of the repository that I have here. So moving on. Back in the terminal, all you need to do is type git clone followed by the URL that we just copied, which is basically the address of our repository. So you can optionally share your output in the chat section. It is very important to note that you did not simply download the code, you download a Git repository. So a Git repo comes with a special folder called .git. You don't need to know a lot about this folder, and just keep in mind that it connects your local project to the project on GitHub. So when I go back on GitHub, you can see that I have the option to clone it and I have the option to download a zip file of the repository. When I'm downloading a zip file of the repository, I might not have, the GitHub, the .git file work as expected. So cloning a repository basically ensures that we have, the whole history of the project with us. So whenever we contribute, whenever we add anything to it, we add a new version on top of the previous one. So it's easier for us to roll back to the previous version. When you're working with a downloaded Git folder, it might not be as Git friendly. So going back. So here you can check out how to make changes to your repository. So whenever you clone a repository, you need to change your directory into the repository that you cloned by typing the command below, which would be cd, which is change directory, followed by the name of the repository. So note that you need to substitute the placeholder name with the name of your repository. So we are going to make some changes. You never want to commit directly to main. So it's standard practice to actually work with a new branch. So we did this in the browser before. Let's actually see how we can do this using the Git CLI. So we checked out a command called git branch, but once you're done creating a branch, you sort of need to enter that branch to make changes. Now, we also have another command which lets you move into that branch, which is called Git Checkout. We can also create a new branch and move into that branch with just a single command, and that would be Git Checkout, followed by the B flag, which signifies that a new branch needs to be created, followed by the name of the branch. So simply open your project folder in the code editor of your choice. For example, if you have Atom installed, you can use the command below to open the project in Atom. If you're using Visual Studio Code, you can just enter code followed by a full stop. So make any changes that you want to your README and save them. So I am not going to be giving you a demonstration about all of this stuff. This is something that you need to try on your own. And if you're stuck at any point of time, feel free to let me know, and I would be more than happy to help you. So again, return to your command line and type the command git status. The output tells us that we have modified the readme.md file at this point of time. So at the bottom, it tells us that we have not added any changes to commit. So we can just commit all the changes now. So you need to type the command below. This command gets your changes ready to be committed. You're basically staging all the changes using the git add command. So all you need to do is execute git space add space readme.md. If you enter git status again, you will see that now the changes you made to readme.md are ready to be committed. So when you commit changes, you will include a commit message, and this message should be descriptive of your changes, which is again a standard practice for your first commit and pretty much every other commit to have a good description that identifies all the different features that you have added. And it's standard practice for your first commit to be named first commit or initial commit. So moving on. Now for a cool Git trick, we want to push the changes that we have committed up to GitHub. Simply type git push. This technically is incorrect, however. Git will tell you the correct command if at any point of time you're stuck and you're executing the wrong commands. So copy and paste the command and add the same to add your local branch to GitHub and commit your changes. So the command that we usually use to push updates is git push origin followed by the name of the branch. But right now we need GitHub to identify the branch that we just created. So the process is going to be to add a flag called set upstream origin new branch. So the new command that we are going to use is going to look like git push set upstream origin new branch, or the branch of your liking, whatever branch you created previously. So you will need to enter your GitHub username and password now, because earlier we just configured our username and email. We did not facilitate our password. And of course, GitHub needs to ensure that it's us trying to make changes to the repository. And you might see that nothing's visible when you type your password, and it's absolutely normal. Now going back to creating a pull request, you can successfully create a pull request in the browser just like you did before by going to the URL provided in your terminal. Once you're back, you already saw the process of creating a pull request. It's going to be the same. You simply need to click on select, compare, and you simply need to click on compare and pull request. And then you need to name your pull request appropriately and then select create pull request. Finally, because you are now the owner of your own repository, you are the maintainer of the repository, you'll be able to merge your own pull request. Now you want to make sure that your local main branch matches the main branch on GitHub. So return to your terminal and type the command below, which would be git checkout master or Git Checkout main, because now all of the default branches that we have on GitHub go with the main branch as the default branch instead of master. This was actually done previously. So simply use Git Checkout main in your terminal. So finally, once you're through with everything, pull the changes on main down to your local repository with the command that is git pull. And now you should be able to see all the changes in the browser. And that's pretty much it. Any questions for me? Any questions that I can answer?
Do I need to get Git in order to use GitHub is the question.
Not necessarily. You don't need Git, but when you're working with complex code bases, it's advised that you work on your local coding environment, because it makes the process a lot better, and it helps you bring your workflow. It helps you basically work with extensions, all of that stuff that are usually not available on GitHub's editor. So it's not a compulsion for you to use Git, but it's definitely advised. So any other questions that I may answer for you? So that was pretty much it on how you can collaborate using Git and GitHub. If you have any doubts, any queries, please feel free to reach out to me. Even after the session ends, you can always reach out to me on platforms like Twitter and LinkedIn. I go by the same name.
Do you have an email address that you're willing to share with people, or?
Sure, I can just add my work email here. So if you all have any questions.
And Aaishika is going to share the slides with me, and I will be sharing them in the same place the recording will go once we get to that point. Excuse me. Well, Aaishika, thank you so much. We weren't sure if we needed as long a time as we needed for the other sessions, but that was very informative, and we appreciate your time. And it was 7 a.m. in the morning for her, folks, and I think she did a fabulous job. Let's all give her a round of applause. Clap your hands, use your little emoticons. They don't make noise, but it helps.
Thank you.
So
thank you so much. Really appreciate it. Thank you so much for the kind words.
You're welcome.
Hopefully the session was informative. And again, if you all have any questions, any doubts, any queries that you'd want me to help you out with, please do reach out and do contribute to open source. And yep, that would be pretty much it. Thank you.
Thank you. I'm going to stop recording now.